So this is my last hat. I thought I'd wear my commencement mortarboard. Since we can't have a commencement ceremony, this is about the best we can do. So congratulations to all of the graduating seniors in biochemistry. Today we're going to talk about the Chapter 15 worksheet. This chapter covers lipids, and there's only a few things I'd like you to know about lipids before the final test. One of them is to be able to distinguish between sphingolipids and glycerophospholipids. Those two lipids have different alcohol backbones. Sphingolipids have sphingosine as the alcohol backbone. That's comprised of two hydroxyl groups, an amino group, and then a long hydrocarbon chain. Glycerophospholipids have a simpler alcohol. It's the triol. It's got 3 carbons, so this would be 1, 2, 3 propane triol if you want to do IUPAC, but the common name is glycerol. So much more simple compound, and probably the easiest way to see the difference between the two is there is no amino group on this. There's an amino group on the middle carbons for sphingosine. In this picture, you see this long hydrocarbon chain, so that makes it look different also. But when you attach the fatty acids to these two alcohol units, they start looking pretty similar, and that's what's in the next picture. So for this question, you had to add a fatty acid to the sphingolipid of this nomenclature, and then for the glycerol, you also had to add some fatty acids. So let's look at the complete structural picture. And again, this is already posted on EDUCAT, so you don't have to write anything down. So for both of these lipids, when we make them into a phospholipid, we have to add a phosphate group. So that goes on the N carbon. So that oxygen now connects to a phosphate, double bond O, O minus O, and then you need to put an alcohol head group here. In this case, I asked for choline. So the alcohol head group is this choline molecule, which is a quaternary amine. The fatty acid goes here on the amino group, so it becomes an amide linkage. So remember, fatty acids have carboxyl groups and then a hydrocarbon chain. How do we know to put this double bond here? That's the nomenclature here. So it's got 12 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It has 1 double bond, that's there. And then the delta with the superscript 6 means the double bond starts on carbon 6. And that's starting with the carbonyl carbon. So remember, this used to be a carboxylic acid. So the carbonyl carbon gets carbon number 1 due to the higher priority of the carboxyl group. So it's 1, 2, 3, 4, 5, 6. So the double bond starts on carbon 6. The other position that would normally have a fatty acid for something like a glycerophospholipid is occupied by the built-in hydrocarbon chain. So when you make a sphingolipid, you only add 1 fatty acid. You make an amide linkage. So that's what you should look for when you're trying to figure out if it's a sphingolipid or not. The other one is a glycerophospholipid. So here's the glycerol, here's our phosphate group. And we made this one phosphoserine. So here's the phospho, and then we add serine, the amino acid, through the phospho link. So this is the side chain for serine, CH-450. You drop the H and you make it into that oxygen linkage with the phosphate, and then the rest of it's just the serine. Then we had 2 fatty acids we had to attach. It doesn't matter which one you put where, but the 2 other hydroxyls will then become ester linkages with fatty acids. So stearic acid has 18 carbons, so I put that one here. So 1, 2 plus 16, so 16 CH2s in the middle would be stearic acid, 18 carbons. And then the other one was arachidonic acid, and that one is a 20 carbon fatty acid. We've seen it before in prostaglandin synthesis, and it's got 4 double bonds. So our carbons are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and 4 double bonds. Those would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 5, 8, 11, and 14 would be the superscript. So it would look like this. if you're going to write it in the shorthand nomenclature. 20:4. So 20 total carbons, 4 double bonds, and they are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that's how you get the nomenclature for a fatty acid. So for the final test, you should be able to take a structure of a fatty acid and come up with this nomenclature. And on the test, since I don't think you can draw or write a delta, I would like you to write it like this: 20:4 delta 5, 8, 11, 14. That would be the same thing. Now what about stearic acid? How would you write the nomenclature like this for stearic acid? Well, you count the number of carbons, it's 18. So you write 18, colon, and then no double bonds, it's a fully saturated one. So you just write 18:0. Okay, the only other thing on this one that I think I need to go over, the rest of it was answered on the answer key, which is pretty straightforward, is the last question, and that is steroids. So steroids all have this fused ring system here with 3 6-membered rings, 1 5-membered ring stuck together. If you see that, you have a steroid. The steroids differ based on the side chains and the functional groups on this fused ring system. So for example, cholesterol has a hydroxyl here, and it has a double bond here. That makes it cholesterol, in addition to some hydrocarbon groups attached. So if you have other steroids, their functional groups are going to change, and they might have different methyl groups or different hydrocarbon attachments. So finally, the last thing is I have 5 of them listed here, and we have their functions. So be able to come up with the functions of common steroids. This will probably be a matching thing on the test. And obviously you can look this up. And the other thing is to be able to recognize the structure of the fused ring system. Okay, that's it. Good luck on the final.